Thora. Markert, so Vasilios himself, is head of AI security and trustworthiness. Thora is head of AI research and governance, and both of them will bring us up to speed. Welcome on stage. Hey.
So thank you very much, Zach, and good morning to everyone. Let's start talking about AI, especially about a very special topic of AI, namely trust. So what does it mean, trust in AI? And together with my colleague Thora Markert, we want to highlight the questions: what is trust in AI? What contradicts trust in AI? And how to achieve trust in AI? And before we dive deeper into the topic, just a brief overview about our background. As Zach already introduced, we are working for TÜVIT, which is part of the TÜV Nord, and I think the most of you got in touch with the company if you own a car. But besides this car stuff, we do a lot of more interesting things, starting from classical IT security stuff up to post-quantum security, and at my area, the safe and secure AI. So this is, let's say, a broad range of domains we have to deal with. And let's start with the topic trustworthy AI. So what does it mean? We heard a lot about new opportunities of AI, so using chatbots, using computer vision applications, and so on. But every new opportunity brings new risks and a lack of trust on the table. And the reason of this non-trustworthiness in AI is based on the following. So this is just a very simplified overview about what is the magic of AI. So let's say if you look under the hood of an AI application, if you dive into the source code of an AI application, you're just facing numbers. So AI is just based on numbers which are aligned or defined during a training. And at the end of the day, these numbers interfere with other numbers and eventually causing a result, just one number, which stands for a certain class. In this case, it's a bird. So this is the whole simplified, of course, magic of AI. And this is the root cause of the lack of trustworthiness. And the reason is if you have both sides on the same table. So let's say on the left side, you have a common traditional application which relies on common software. So the developer implements the rules, you can track the rules, and in case of an error, you can look into the source code, and maybe you are successful to find the bug and fixing the bug. In contrast to this, if you dealing with AI applications, you just have this bunch of numbers. And looking in these numbers, it's meaningless. So you cannot derive any rules or behavior or predict even the behavior. It's like a black box. This impacts a lot of applications if you have to deal with safety critical, security critical, or privacy critical domains. And to highlight the special topic of trustworthiness, so what does it mean if we talk about a trustworthy AI application? Unfortunately, the word trust in AI has a lot of different meanings. So if you ask an AI developer, do you trust your application? He may answer, of course, I have tested my application, I collected some great testing data, and I have a great accuracy. And the common way to test applications is as follows. So I think the most of you are pretty familiar with this approach. You have the training phase, you have made a very good training data set, in this case, a lot of images of birds. And then after a successful training, you use your test data set, maybe hundreds of thousands of examples of birds, and then it turned out your model, it's pretty accurate, you have a high accuracy, and then rolling out your AI application in the field, and you have to deal with unseen data. So this is the, let's say, most common way to develop applications and to elaborate on a number of trust. But what does it mean, the value of accuracy? is now our AI application trustworthy or not? I want to explain this topic using a short examination. So imagine a following scenario. You have a pretty motivated AI developer and they trained an AI model and now using a tremendous amount of testing data. And it turns out we have a pretty good accuracy. So now the question is, if we take a new picture this was not included in this data set, so what is the right answer? Will this image be classified correctly as a bird? What do you think? Yes, no, or I don't know. So unfortunately, the right question is C, I don't know. I have no clue if this picture will be classified as a bird. Even if I take this image from the data set, changing only one pixel, I have no guarantee and no indication if this image will be classified correctly. Don't get me wrong, so neural nets or AI itself is very robust. It's one of the key advantages of AI, but the robustness is not predictable. And this is the major issue causing a lot of concerns using AI in critical domains. And now you may ask, okay, let's test every scenario, testing every input data. The bad thing is you cannot test every situation, every scenario to be on the safe side. So, so do we have to trust just AI, or can we do something to bring a little bit more trust, more light in this black box? The next bad thing is the list of, let's say, of the security or threats of AI is very long. So in case you have to deal with computer vision, you have to deal with this uncertain robustness. You may have to deal with data poisoning. Maybe you have to deal with information stealing or information extraction, which is relevant in the data privacy domain. And in terms of generative AI, you have to deal with prompt injections, with hallucinations, and so on. And this animation is an actual example of one of our demonstrators showing an AI system trained to recognize traffic signs and works pretty well. But once you distort the input image by a simple mug or other patches, the AI thinks this is a completely different traffic sign. And of course, this lead to very safety concerns in the field. And of course, this is it could be very funny, but the real fun starts if you try to assess your AI application. So imagine you are an AI engineer working in a security or safety critical domain, and now let's start to assess our application. On the left side, you have a lot of frameworks supporting this task. They're helping you, giving some guidance, how to test an AI component and a software component, because AI is just a software component at the end of the day. So what does it mean? So if I use best practices from the safety domain, like unit testing, or from a security domain, like penetration testing, if I have to assess my application regarding privacy concerns, like the right to forget whether my data is anonymous or pseudo-anonymous, and so on. So can I directly apply this kind of best practices to my AI application? Yes and no. So of course I can, or it's possible to apply this kind of methodologies to the current software in which my AI application or my AI model is embedded. But if it comes to the AI model itself, it's not possible to directly conduct these kind of tests, because we heard about that in the AI model is just based on numbers, and conducting these kind of best practices, the result is meaningless. So we have to deal with other testing, and we have to conduct new methodologies to gain insight in this black box. And how would it look like in the real world? So if you go to assess your application regarding privacy, on the left side, this is a result based on our let's say an assessment of an AI model, and the goal was to check whether the trained model, so the data which are somehow stored in this model, are completely anonymous. Because in terms of completely anonymous data, you don't have to deal with privacy topics. And conduct some approaches from the research or from other best practices in the privacy AI field, you ended up in a reconstructed phase, which are pretty similar to the original training data. So what does it mean? So if the developer stated, okay, after the training, the data is completely anonymous, so we have to say, okay, sorry, the data can be reconstructed, and therefore it leads to an, let's say, privacy concern. So we have to rework your application, we have to implement some countermeasures to avoid this behavior. And on the right side, if you have to deal with robustness in the safety or security critical domains, one of the best practices, so it's just only a glimpse, an excerpt of the possible methodologies, you may have to assess your application regarding very extreme conditions. You have to assess corner cases. You have to check how your model behaves in terms of unseen data or very, let's say, exotic data, like different background colors of a stop sign or maybe spelling errors and so on. This is just to have a first indication how your model behaves if some strange conditions occur, which was not included in your training data. And even in the explainability part, you may have to conduct some explainability techniques to gain insight on which features your model relies. So for example, this image shows the parts which are contribute to the decision of the model. So for example, every pixel which is highlighted contributes to the decision that this guy is recognized as, let's say, Max. And you will agree on that structures of the face could be very crucial, but even the background is relevant for the decision, which is not intended and may cause a lot of trouble. And so far, the bad things, yeah, it's time to that Thora will take over, and Thora will describe how you deal with these kind of issues in terms of the upcoming regulation, namely the European EU AI Act. Thank you.
Yes. Let me bore you before lunch. So basically, Vasi just showed very interesting testing, how you can do it like technically, but now it's kind of my opportunity to bore you a little bit with the compliance and regulation and how to translate basically the EU AI Act into these tests, or if it's even possible already to translate some of these tests into the EU AI Act. So just so everyone is on the same page, which I think you probably all know, but the EU AI Act categorizes for risk classifications for AI systems. It's based on the risk of the AI system or the threat of the AI system to the safety, livelihood, and also fundamental rights of EU citizens based on the EU law. So it includes some things like discrimination laws, general health and safety. And it goes from basically forbidden, so you're not allowed to use these systems, to minimal risk. And just as an example for the forbidden risk category, it's basically things like AI-based surveillance in public spaces. So this, on this side, is, for example, one of these rumored public scoring systems, as they're used in some countries, rumoredly, but so these things won't be allowed, or also some tracking related to public spaces like a cafe or something, where customers are also tracked in public spaces. So what does this entail? So the risk categories that actually have to undergo some deeper testing are basically just the high risk and limited risk systems, whereas the limited risk systems, they just have to do some transparency obligations, so it's not not really a lot of effort. So when it comes to high risk, it's basically the most effort you can have when it comes to AI systems. And these systems include, for example, HR applications, financial applications, also things like migration and law enforcement, but also biometric applications or critical infrastructure. Now we also have to think about, there's a lot of products that are already have to be compliant with other EU regulations, other EU laws. And these also automatically, if they entail an AI system, fall under the high-risk category. So if you have a medical device, for example, it's already regulated under EU law. So your AI system that is part of your medical device is also a high-risk system automatically. There's a bunch of different EU laws. So for example, toys are regulated, radio equipment, maritime equipment, civil aviation, things like that. So it's a lot of products that are actually already regulated. They will be further regulated by the EU AI Act. So what is the timeline, which is probably interesting for some of you. So the EU AI Act took into force in August of this year. The first regulation that will come into place is the one for unacceptable risk AI systems, which is February next year already. So by then you are not allowed to use them anymore. I hope you don't have any of these systems anyways, but don't use them. From August 2025, it's already the GPI systems, so Gen AI systems, LLMs. Then August 2026, the high-risk systems that are not regulated under a different EU law. And then a year later, in 2027, all high-risk systems that are also regulated under EU law, other EU laws have to be compliant to the EU Act. This is done because they gave a little bit more time to basically adjust the already existing conformity assessments to the EU Act. So again, for the high-risk systems, you have two deadlines basically. If your system is from the first category, 2026. If it's from the later one, 2027. So what are the requirements basically? The requirements start basically from some data management, data quality requirements, going over to documentation. You need to have a really intensive technical documentation that you submit to the AI office basically. Transparency obligations, so you have to say if someone is communicating with AI, things like this. Human oversight, so to minimize some harm to humans or some safety concerns. Do you have human oversight in place? How is it carried out? Things like that. Robustness, accuracy, and security, which is basically part of what Vasilios showed you before. And then also testing, validation, and certification, which is also what Vasi showed you before with the tests and things like that. Yes, and also you have to have a risk management system, which, yeah, there's basically just saying, how are you going to mitigate some risks that it entails by the system? So for example, safety risks and things like that. So for GPI, which is the first thing that is going to be regulated, that you have to do something for basically, it's very complex because the thing is, the EU Act is very high level. So if you're a developer or someone that works technically, it's very hard to use the definition by the EU Act to basically derive anything you can use for it, because the EU Act just says, okay, a GPI system is a system that has a large amount of training data. What does that mean? What is large, basically? It has to have a very high level of generality and perform a wide range of different tasks. And also, yeah, so some research, development, and prototyping is before it accesses the market is still allowed. But yeah, basically how to quantify these things, it's very hard because yeah, there's not really any values attached to this. It's even more harder when you look at systemic. So there's also another category for GPI system, which is GPI system with systemic risks. So things that could harm any humans, basically. And this is even harder to tell because they have two definitions. One is you have a cumulative computations used for training above a certain number of operations, floating point operations, but it can also be defined by the high impact of capabilities, which is a number of different things. So basically, the amount of parameters you have, the quality and quantity and size of your data, input and output modalities, or something like the number of registered users. So there's no really clear definition. For the requirements you have to oblige by, for the GPI system is copywriting, also documentation transparency, we already had that. You have to follow the code of practice that will be released soon, and you have to give info to your providers how to incorporate your system. If you are a GPI system, you also have to keep in mind, can also be a high-risk system, then also the different other requirements will oblige to you. For the GPI system with systemic risks, things like model evaluation, risk assessments, incident reporting, and also cybersecurity testing has to be performed. So for the compliant, it's really hard also to be compliant because there's no finished standards or very few finished standards. So you don't really know how to define a GPI system, but you also don't know how to be compliant because the standards are not finished yet. So it's a really, really difficult landscape at the moment. But basically what you can do is obviously incorporate trustworthiness by design at the first start of your design stage, basically. Then do extensive testing, also continuous monitoring of the results of your system, especially for the parts like incident reporting, things like that. And also, we have to say, because we're TÜV, audits. Audits are always very important, but they are actually test requirements you can derive by combining existing frameworks, some standardization that is domain-specific. So for example, if you have a medical device, there might be some standards that you can translate to the AI domain, and also some of the already finished standards for the AI systems. Yeah, and that's it, basically. So
thanks a lot, Thora and Vasilios. Fun fact, later during the barcamp session, you can also get a tour through the building because we have the drivery in here. And when I came in, I saw they have an actual DeLorean down there that they're trying to rebuild from Back to the Future. It seems like they're making some progress. So that's the future knocking there. But are there any questions? One question back there. All the way in the back. Oh, yes.
Hi. Thank you very much. I wanted to ask, since it's unlikely that there will be a lot of people going on and developing their own big AI model, mainly foundational models that are already there will be used, is there a chance that there will be classes, you think, of some foundational models that come pre-certified by TÜV, and then when you use them, then you can just go through the normal software evaluation for TÜV without having to be concerned about that part as well?
So there's actually some limits to that. If you do some fine-tuning, so if you do any changes to the model, you have to oblige by some different rules. You also have to do some testing as well, and some conformity assessment. But if you don't change the model, you use an already pre-existing models, you just provide it, you have to oblige by some transparency rules, just that they are using the AI system, things like that, but you don't have to do extensive testing anymore.
Wonderful. Okay, one more question, quickly.
I have one question. Actually, I want to know about the adoption of trustworthy AI in a German market, especially when the country is still preferring paper communication instead of digital services. So how do you think that adoption?
Oh, sorry, I didn't really get the question because of the noise.
Sorry, I will repeat. I just want to understand the adoption of trustworthy AI in German market, because still, if you see German market still prefer paper communication instead of digital services. So with the, like in this market, how do you see like Gen AI or trustworthy AI or this kind of technology adoption in the near future?
So basically, I think trustworthy AI, especially in Germany, is very important because we have such different cultural approaches when it comes to digitalization, in comparison to other countries, especially our neighbor countries, they are much more forward in using AI systems. There's a lot of mistrust in these systems in general, in the general public. So I think basically the trustworthiness coming out of Europe or Germany itself will become like a big driver and people actually using it. It's becoming more commonly adopted. And this will also, I think, influence other industries. If you see, for example, the cybersecurity industry, cybersecurity certifications or data privacy certifications that come out of Germany are much more higher valued also in different countries than certifications from other countries, basically.
Thanks a lot, Thora and Vasilios.